Hello everyone and welcome back. This is Mr. Keeney and we're going to be continuing to talk about geometry today, section 2.5 notes, continuing to use our reasoning, deductive reasoning to form a logical argument. We've been using theorems, we talked about postulates a lot last time, and then we're going to be using definitions to prove and apply theorems about angles. And actually today we're going to be focusing on some fundamental logic, and we're going to do that by bringing up something that I think we're pretty good at already, which is algebraic equations, which would be linear equations where we're solving for a missing variable. When we do this, and I'm going to go ahead and just get going right away, these algebraic properties let us kind of simplify, if you will, or solve or deduce what this missing variable would be. So for example, to start over here, if I were to have x minus 4 equals 10, and I want you to find out what x is, a lot of you guys would look at this minus 4 and want to cancel it out by adding 4, which you would know you would have to do to the other side, which is absolutely correct. So I would get x equals 14. Now this idea right here, and specifically, actually, let me go to the step that really we're going to be talking about. This step right here of adding 4 to both sides. It's a strategy, it's a tool, but more than anything, it's a property of equality. It is the addition property of equality. It says that if I have A equals B, if I have an equation, then it's okay if I add something to the left side of my equation as long as I add that equivalent, B, to the other side as well. So when I use the addition property, in this case it was plus 4 to both sides, I know that I still get an equivalent equation down here. So we are going to be talking about these reasons that we are using, and we know that they are true, but we really want to be intentional about what we're doing, what steps justify getting from start to finish. So in algebra, you were more worried about getting to the end, getting the answer. And today I want you more to worry about how am I getting to the answer? What is that journey to get there? So sometimes on that journey we use addition property. Sometimes we use subtraction property, which says if I have A equals B, then I can subtract the same thing from both sides. In this case, I'm going to use C again. So A equals B, then I know A minus C equals B minus C is an equivalent equation. A multiplication property would be the same thing. A times C equals B times C. And division property, I think you guys know where this is going here. I can divide by the same thing both sides as well. So these four kind of operations here, addition, subtraction, multiplication, division, we use those a lot when solving equations. And then I put two others here. Substitution property says if A equals B, then B can be substituted in for A. B can be subbed in for A. And what that is, let's say we go and we work out a problem, we get x equals 3. Sometimes we want to take it and go, okay, if we have 3x plus 1, I can substitute 3 in for x. So it would be 3 times 3 plus 1, which would be 9 plus 1, which would be 10. So we use this a lot when we are supposed to solve for x and then plug it back in. We've actually done that this year, I think, a couple times as well. So substitution property lets us do this step here, which is, okay, if x equals 3, I get to sub it in for x and turn that into 3. So substitution property, something that we've used quite a bit already this year and in years prior. And the last one, distributive property, which we'd like to draw these little arcs or rainbows, whatever you want to say. And it says A times the quantity B plus C equals A times B plus A times C. Distributive property. I can't talk. So we're just going to solve these equations, and I'm going to, the big thing here is write a reason for each step. So if you want to try to solve this by yourself, right now would be a great time to pause, but make sure that you're giving a justification. So 2x plus 3 equals 9 minus x. And you know what? I'm going to get you guys set up in a way that I want to make sure that you guys will be able to use. So we're going to be doing two columns. We're going to have statements, which is where the equations today will go. And on the other side, I want a reason for each step. So if this were step number 1, the reason is this was our given equation. And when we do proofs, it will always start with given. We have given information, and we're going to be trying to get to our conclusion. Now from here, I'm going to use a different color for my work. if I were to solve this, I would want to, if it were me, add x to both sides. Feel free to use whatever method you want, and I would get 3x plus 3 equals 9. Now, the reason I could do that was the addition property of equality. So addition property of equality. And I might shorten that down here a little bit, but I want to make sure I write it out. I added x to both sides. That is the reason I was able to do so. So we're going to continue to go. I'm going to subtract 3 from both sides, which when I do this, I will get 3x equals 6. And the reason for that is the subtraction property of equality. I'm going to put POE just to save myself some time. And then the last step here would be to divide by 3. And I know it's my last step because I've now have figured out what that missing variable is. And I used the division property of equality. So again, I'll do POE. So there is every step justified. So again, today I want you guys more worried about how I'm getting to the end rather than just getting the answer, just getting the end. So we'll do one more here, statements and reasons with a little bit of sloppy handwriting. That's okay. And they started off with the equation -4 times 6x plus 2 equals 64. And again, we are always starting off with our given information in these proofs. So let me use a green this time. The first thing I would do is distribute. So I would have -24x minus 8 equals 64. And I realized that was actually, I didn't have to do that in a different color. So let me erase this here and go back to my pretty blue color. My work was just doing the little rainbows. There we go. And that was distributive property. Distributive property. And with distributive property, I just like to put distributive property, that we're not using the equality on both sides. Now we'll use the green here. So I would add 8 to both sides, and I'm going to show what it gets me. So I'd bring down a -24x equals, and then 64 plus 8 is 72. And the reason for that would be an addition property. We added both sides by 8, so I'll do addition POE, property of equality. And then my last step here, I want to get x by itself, so I'm going to divide by -24. And we get x equals -3, a good old division. Oh, and you're going to be hearing...
Can you come to the front office or call 3000, please?
I don't know if you guys can hear that, but the intercom just came on right now. So a little Easter egg. You guys will hear me at work. That kind of scared me. Okay, moving on to other tools in our toolbox that we're going to be able to use in these algebraic proofs and geometric proofs moving forward. The first one is called the reflexive property of equality. And for what it says is that for the real numbers, for any real number a, so 1, 2, 3, 4, any number, we can say that a is equal to a. Something is equal to itself. So the reflexive property says number is equal to itself. For segments, it would say the length of segment AB is equal to the length of segment AB. And as you can probably guess, for any angle A, we could say the measure of angle A is equal to the measure of angle A. So it's the reflexive property, reflexive property that says something is equal to itself. Next one is the symmetric property of equality. And it is, I like you guys to think of symmetric as symmetry. For real number A and B, if we know that A is equal to B, then I would also know that B is equal to A. Order does not matter here. Same for segments. If AB equals CD, then I can say CD is equal to AB. And as you can probably guess with angles, the measure of angle A equals the measure of angle B, so I can conclude that the measure of angle B equals the measure of angle A. So order does not matter. We can switch symmetric switches. So what I like to say to myself is reflexive repeats and symmetric switches. Just a little mnemonic device there. And the last one here, transitive property, which uses A, B, and C. It says if A is equal to B, and B is equal to C, we're going to draw this little arrow here. What I can say is that A is equal to C. kind of with the same thing with segments. A is equal to CD, and CD is equal to EF. So I'm going to go through CD, through that middleman, to say AB is equal to EF. All three of them are equal to each other, so I could say that AB equals the F. And then finally, the same thing here. I really like drawing this arrow to kind of say I'm going through the same thing here. Measure of angle B, measure of angle B. A has to equal C. Now this one, and you'll see down here, there's a little bit of a good representation of the transitive property. Transitive property, remember, we're going through the middleman to say that AB is equal to PQ in this case. So I'm defining that AB is equal to CD and CD is equal to PQ. Substitution would be taking this information to say, okay, if AB is equal to CD, and I know that PQ is equal to CD, so what I'm really doing with substitution is I'm going to take PQ and I'm going to put it in its place. I'm going to substitute it in its place here, which is why I get PQ. These are very, very similar. A lot of times I'm very forgiving on transitive and substitution, but try to remember that transitive is going through this middleman. It's a little bit of math grammar, if you will. But that wraps it up for today. You'll have some questions going over algebraic equations and solving them and justifying as you go. Please let me know if you have any questions, and I will talk to you guys later.